Okay, let's try this problem. It's a little more difficult, I guess. It says a 1.00 liter flask contains nitrogen gas at 25 degrees Celsius and 1.00 atm of pressure. What is the final pressure in the flask if an additional 2.00 grams of nitrogen gas is added to the flask and then the flask is cooled to negative 55 degrees Celsius? Okay, so let's just write over here. So N2 is going to be N1 plus 2.00 grams, just to remind ourselves, okay? And we'll put T2 over here at negative 55 degrees Celsius as well, okay? So if we don't do that, we'll forget about it, and we'll forget what we're doing, okay? Or at least I will. Okay, so the first part of the problem really is asking you to figure out what is the number of moles of nitrogen gas that you have, okay? So in order to do that, you got to use your ideal gas law, PV equals nRT, okay? So PV equals nRT, right? And we know R, that's given to us, 0.0821 liters ATM mole Kelvin, like that, okay? So we have this, and this. Well, this isn't in the right units, right? So plus 273, so it's going to be 298 Kelvin. Now, that's in the right units, in the right units, in the right units, right? So let's rearrange our equation. N equals PV divided by RT. Is that right?
Yeah.
Okay, wonderful. So now we can plug in all of these numbers. Okay, so pressure, 1.00 atm. Volume, 1.00 liters. Divided by R, 0.0821 liter atm per 1 mole Kelvin, and 298 Kelvin, okay? So cancel, 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 cancel. So, what do we get? So 1 divided by 0.0821, and then divide that by 298. So the number of moles that we get, is anybody else doing this on the calculator as well? Are you just following along? That's all right. The number of moles we get are going to be 4.09 times 10 to the negative 2 moles, like that, okay? Okay, so that's how many moles of nitrogen gas we had to begin with, okay? Can I erase all of this business here? And just, I'm going to leave this, okay? I'm going to leave that. I know I'm going a little fast here. It's for the camera though, you know, so. Okay, so we're going to call that N1, okay? So look over here. We got to figure out, well, what is N1, or N2, and we know N1, right? And this is 2 grams, but that's not moles, right? So we're going to have to convert that to moles, okay? So let's do that first. Well, what do we know about N2 gas? Well, nitrogen itself is 1401 AMU, so N2, the molar mass, is going to be 28.02 grams per mole, like that, okay? Does that make sense? Okay. So 2 grams, well, we should be able to figure out how many moles 2 grams is, right? Okay, so let's figure out what is the number of moles in 2 grams. So 2.00 grams times, at the bottom here, 28.02 grams, 1 mole. cancel, cancel. So that's how you do. Remember when you were asking me that question
Yes.
earlier? That's
Yeah.
how you do it, not how you were trying to do it, okay? So, 2. Okay, so 2 divided by 28.02. And we get 7.13 times 10 to the negative 2 moles, like that, okay? So that's that right there. So N2 is going to equal N1, 4.09 times 10 to the negative 2 moles, plus 7.13 times 10 to the negative 2 moles. So, plus, so the total number of moles now is 0.112 moles of N2. Okay? Does that make sense what we've done? Because we're adding 2 grams to that flask. Okay? But not only did we add more gas to it, we cooled it down. Okay? So this temperature, remember it's no longer 298 Kelvin, but it's negative 55, right? So let's store this one. Okay, so negative 55 plus 273, right, is going to give us 218 Kelvin. Like that. Okay? So notice it didn't tell us that we changed the volume of the flask, nor did we change the the pressure. Okay? So we're going to do PV equals nRT again, except now we're not going to use that one. We're not going to use that one, but we're going to use, sorry, and we're not going to use this one, right? We're going to use those things over there, okay? So what are we looking for? I can't even remember anymore. It says the final pressure, okay? So, right? Okay? So, let's do it. PV equals nRT. So, P, we are using this. I want to cross that out more. Okay? P equals nRT divided by B, like that. N, where is it? 0.112 moles. R, 0.0821 liter ATM per 1 mole Kelvin, like that. Temperature, 218 Kelvin divided by volume, 1.00 liters. Cancel, 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 and we get pressure there. Okay? So, let's do it together. So, times 0.0821 times 218 divided by 1. So what's the new pressure that I get is 2.01 AT. That's the new pressure. Okay?
When you saw that, it's simple, but when I look at this, it's
a lot. You just got to be very logical with the steps. You know, you got to do it. Okay, what do I know here? And then figure that out. And then from there, you got to think, okay, what is it telling me now? You know? and then come over here and do this stuff. And then it's just PV equals nRT once, and then PV equals nRT again, you know? So you're doing it one way first, and then kind of a little bit backwards the other way. Remember I told you that at the beginning? Yeah, okay. Does it make sense?
I look at the video.
Okay, yeah, sure, just watch it. Any other questions before we kill it? Okay.